present my research title, Wide Area Fault Detection and Location for Transmission Power Network. So for the introduction, faults in power system can occur due to many factors such as tree or current encroachments, animal intervention, lightning strike, human error, and etc. So when a fault occurs, it must be isolated as soon as possible so that so it will not affect the power system security and also reliability. And also when a fault occurred, it must be located as soon as possible so that the repair works can be carried out. So for the problem statement, for the conventional fault location, the utility workers have to go to the substation to extract the fault information from the installed protection relays. So this process is very time consuming and it will make the faulted line to be re-energized at a delayed time. And then for the proposed solution, we propose the 5 rules to determine the PMU placement or the measurement points in the power network. And then we also propose the wide area fault detection to determine the faulted line in the network. And finally, we propose the wide area fault location method to estimate the fault location for the faulted line. So advantages of the proposed method: by using the proposed method, the fault information can be gained directly from a central location without the utility workers having to go to the substation to extract the fault information. And the method also can detect and locate the faults on homogeneous and hybrid circuits which have the combination of cable and overhead line. And also the proposed method is not affected by the charging current of the long lines. So this is the proposed 5 rules of PMU placement strategies. So the first rule, the buses with 1 or 2 connected lines will not be selected as the PMU bus. And then for the second rule, the generator buses will be set as the PMU bus. And for the third rule, the remaining buses that have at least one line connected to the PMU bus at the remote end will not be selected as PMU bus. For the fourth rule, PMU will be installed at the remaining buses, which will produce a high number of buses with at least one line connected to PMU bus at the remote end. And finally, for the fifth rule, the PMU will be installed at the remaining buses after rule 4 has been performed. So based on the rules, we have developed the systematic PMU placement for chart, which can be implemented on any kind of IEEE bus system. And this is the proposed wide area fault detection method. There are two proposed fault detection methods. The first one is the method which uses the current comparison. So the current will be compared between pre-fault and fault conditions. And this method used for all lines in the network, and it uses the positive sequence values as the input. And this is the fault detection method. This which is using the voltage checking method. So this method only used for the lines which share the measurement source with other lines. It must be used in conjunction with the first detection method, and it uses the negative sequence values as the inputs. So there are two types of voltage checking method. The first one is the for the common bus which have two connected lines, and second is the for the common bus which have more than two connected lines. And then for the proposed wide area fault location method, it was developed based on the two terminal impedance method, and it was enhanced by using the Kirchhoff current law and Kirchhoff voltage law to obtain the current and voltage for terminal which is not connected to any PMU. And this method used negative sequence the input. So this is the flow chart of the wide area fault detection and fault location methods. So from the flow chart, firstly, the wide area measurements from the PMU, which is located at various locations in the world, will be divided into two. So the first one is for the line we do not share the measurement source with other line. Second is for the line we share the measurement source at the other line. Next, measurements will be converted to the equivalent positive and negative sequence values. Next, the measurement will be passed to the fault detection method to detect whether the fault occurred or not at the line. And finally, if the fault is occurred at the line, the fault location will be estimated from the local terminal of the faulted line. Okay, this is the combination of our area fault detection and fault location method for all lines in a EEE 39 bus system. So each line in the network will have its own fault detection and fault location method. And this is the results of PMU placement on a EEE 39 bus system. So from the results, based on the 5 rules, 12 number of PMUs must be installed in the network. And the circle shows the location of the PMUs in the network. And this is the results of wide area fault detection on a EEE 39 bus system. So all faults has been simulated at all lines in the network. And from the results, all faults has been successfully detected, where the average fault detection time from fault inception is 0.01 second or 1.268 second, which is very fast. And this is the results of wide area fault location on a EEE 39 bus system. And this is the results, the average results of the fault location for all lines in the network is less than 1% and also less than 1 km, which is very accurate. And we also test the methods on different line lengths in the network to see whether the method is affected by the charging current or not. From the test, where the proposed method we choose the negative sequence values as the input was not affected by the charging current of different line lengths compared to the method we choose the positive sequence values as the input. So this is the commercialization potential, where it can be implemented by the electrical utilities such as by the NB, by Sarawak Energy, by SESD, and also by the No Power. Okay, so they can implement this algorithm to detect the fault and also determine the location of the fault line from a certain location without having to go to the substation. And this is a research publication for this research. Thank you.